Okay, good afternoon, all of you. I'm audible. Anybody can respond. I'm audible.
Yes, sir.
Yeah. Okay. We'll proceed today unsupervised learning. In the last class, we discussed the supervised learning. That major thing in the supervised learning, there is a labeled data. Input data will be the labeled data. Whereas the testing everything, once any new data comes, it can easily predict what is your output. Similar fashion, we'll proceed with unsupervised learning. In this unsupervised learning, there is a unlabeled data will be there. So models are trained using the labeled data in the case of supervised learning. You can see here, trained using the labeled data for the supervisor of learning mechanism. But in the problem is many cases the label data is not available because the data itself we need to get it to train and to test the model. In the supervisor learning, we require as a label data. Many cases, what will happen is not having labeled data. The hidden patterns you want to find, what you want to do is given data, we have to give, and from that patterns we have to find, and finally we have to find as a prediction. But to solve such type of problems, we need unsupervised learning techniques, because if label is not there, you cannot apply for supervised learning. That is the reason we have to go for as a unsupervised learning technique. So this what we'll do is training data set. Instead of label, you can go for as a unlabeled data. So the device model can able to train themselves. So find the hidden patterns from the given data. But compared to learning, that there is a human brains. So this is like experience, like anyhow human brain were learning the new things. How the brain is going to be learned? It is nothing but by training themselves. It is going to learn. So after kids, then it will get some age. Then they will be matured. The society, how it will be impact everything. Nobody will train by nature. It has to be train our brain. So the same way we are going to learn in the unsupervised learning as well. Models are trained using the unlabeled data set, allowed to act data without any supervision. Just a minute.
That paper, sir.
Yeah, so here unlabeled data are allowed to act as a data without any supervision. So it what we finally we want is unlabeled data is readily available many cases, but labeled data collection is a complicated, because labeled data case everything we have to get the solution. But in this case, it is automatically going to be act. You can see that directly applied to the regression or classification problems, because unlike supervised learning, input data but no corresponding output data in the unsupervised learning case. But whereas in supervised learning, what we have is there is a input data A and B is there, correspondingly what is our output directly we know that. So that is the case of supervised learning. But in the unsupervised learning, what will happen? We cannot apply this type of data to the regression as well as the classification, because supervised we have the output. That's why we can go for as a regression classification. But in this case, we'll go for as a clustering normally. You can see that the goal of unsupervised learning is find the underlying structure of the data set group, that the data corresponding to similarities. Suppose in a group of data is there in a basket, similarity group of it may be fruits, or it may be symbols, it may be images, or it may be anything. What that will do is that will segregate according to that group. That's what we have. And then unsupervised learning algorithm is given as input data set containing images of different types of cats or dogs or anything. Not only because in a group it may be different kind of data set. It may not be image, anything also. But what they will do is they will segregate the one type is a clustering is a all cats are one clustering, and then dogs are another clustering, like that. This algorithm is never trained upon the given data set, which means it does not have any idea about the future of the data set. Because in this case, we don't know what is the outcome of this. But after training this, it has to identify the clustering. Okay, these are all one category. These are all rest is another category, like that. Identifying the image features with their own. So now it is going to be identified. Okay, this image is related to dog. This image is related to cat, or something like that. It has to given the final answer. By clustering the image data set into groups according to similarities between the images. So what that features it will do it sometimes no cat and dog little bit in similar feature. That has to be trained many number of images that features. What inside it is doing is image will not directly compare. It will convert it into the patterns that is in the ones and zeros, like that. So from that way analysis it will do, and huge amount of data inside operation is going to take place. And finally it has to be identify whether the given image is belongs to as a cat or a dog or something like that. Why unsupervised learning? It helps to find the useful insights from the data. Is one application. It is similar to the human learning by thinking by its own experience, making it. That's what I already mentioned. It is similar to that of artificial intelligence. It works as unlabeled and categorical data with marks. Unsupervised learning more important, because in the real world data do not always have the input data with the corresponding output. Need unsupervised learning. If that is the case, input and output, corresponding output is not labeled, we have to go for unsupervised only. Now we can see here, this is the mechanism is going to be applied in the unsupervised learning. So there is a group. By observing this group, all these groups are bit similar to one category by seeing. But what this will do is there is a this type of images is passing through the algorithm. It may be any algorithm, clustering algorithm, again k nearest clustering, like that. We have many categories are there. Anyhow, that will comes under third in it. This is all about only the introduction of all the types of learning algorithms. And then it will train this mechanism based on this training algorithm. What it will do is it will divide the groups, because here you can see that dogs are there, cats are there, but all the group of images we are passing as input. But what we are expecting in a output side, we need to divide this which image is belongs to cat and which is belongs to dogs. So like that, we can. That's what we mentioned here. Unlabeled data we taken, it is not categorized in the input side, and also we don't know the what is the output of this image. And what we are doing is a machine learning model is you have to use these images for training the model. And first raw data is analyzed, hidden patterns it will be recognized, hidden pattern in terms of the matrix fashion, and then appropriate algorithm you have to select. That's what any algorithm. Anyhow, that different kinds of algorithm will come back again. There is a it consider k means clustering and other type of algorithms also there. Using this even SVM also there, and then decision trees you can apply. And by using this kind of algorithms, we are able to find once if the algorithm is applied, then what will happen? It divides the data object into groups, because it is all about category or clustering. This is one cluster and this is a another cluster. So by passing these images to no unsupervised algorithm, then it will be given as a 2 clusters. If it is having 3 clusters, it will show as a another cluster as well. So like that images. Now we'll go for as a types of unsupervised learning. What are the types of supervised learning? Anybody? What are the types of supervised learning we discussed in the previous class? Classification and regression. And that is the two types of supervised learning algorithm. Similar fashion, in a unsupervised learning algorithm, we have again two types of unsupervised learning. One is a clustering, another one is a association. These are the two things are there. Clustering method is a grouping of object into clusters. So now what we are passing is a group. No, this is belongs to one cluster. This is another cluster, something like that. We are passing the total group. It may be having many categorized, many features, many different kind of images, but it will be identify most similarities in a one group. If it is not similarity, then it go for as another group like that. So finds the commonalize between the data object and then categorize them as part of the previous absence of commonalities. You can say that commonalization is there. We can categorize this is one group. If this group is differ with some other group, that is a one category. And like that features based on their features one by one, we can able to observe that. Another one is a another type of unsupervised learning is association. So association rule is a unsupervised learning method which is used to for finding the relation between the large data set. This will be huge data set. It will be categorized in terms of the relation between one to another like that. It determines the set of items that occur together. Yeah, this is very important. Well, you can also notice that when we are searching, Amazon or Flipkart or anything, what when we are searching one item, let us assume that something you are searching for cake, let us assume that. So what that similarity it will show you, because when cake we are want to buy, in general, we are going to buy as a knife, small knife, or candles. So such type of images also will display you to select. The reason is this: when the person is buying, like I said now in the earlier also, one person is buying as a beer, he may buy for chips or something like that. Or similarity, butter. Suppose you are buying as a cake, normal bread or let it be. And preferably it will show you as a jam or maybe butter. So some similarities it will identify. So that is nothing but a association. So you can see that as makes the marketing strategy more efficient. That way also is possible. Because once if you know that, you can easily marketize and you can sell the product. That will majorly in the companies and all how they are going to be promote their product in that. So now there is a, I said different types of majorly two types. One is a clustering and association. In clustering and association, we have these algorithms. There is a k-means clustering, k nearest neighbor algorithm, and then hierarchical clustering, anomaly detection, and the neural networks, and the principal component analysis, independent component analysis, prior algorithm, and singular value decomposition. Like that, we have different kind of algorithm. And in a third unit, we already mentioned some of the algorithms names. We'll discuss only that. But apart from that, many of algorithms are available even for supervised learning as well as unsupervised learning as well. What we want to do is whatever type of algorithms we have, but we will restrict in the class for the specified algorithms which were discussed in the syllabus. So, but we have a lot more algorithms in each category, and you can see that clustering also. There is a exclusive, agglomerative, and then overlapping and probabilistic. So this type of algorithms are there. And again, clustering types also there. K means and then hierarchical clustering, principal component analysis. That's what all these points I already mentioned in this side as well. So these are the different kinds of algorithms. Now we can see advantages of supervised learning. What are the advantages? It does not require training data to be labeled. What is our training data? Input data you are going to train actually. This training data to be labeled in the case of supervised. But in the case of unsupervised, it does not require. Directly we are passing the images. It may be cat or maybe dog or elephant or anything. We are passing simply and it will segregate it. Dimensionality reduction can be easily accomplished using unsupervised. In third unit, fourth unit, you can see dimensionality reduction techniques only. So this is one of the method in unsupervised learning we can able to do dimensionality reduction technique. Capable of finding previously unknown pattern in a data. This is having a more capability, previously unknown patterns in a data. So in the data, whatever unknown patterns are there, or hidden features, all these things is able to identify. And another one is flexibility. Then can be applied a wide variety of problems, including clustering, anomaly detection, and association rule mining. These are the methods are available in a flexibility. And exploration also is one of the advantage. You can see that allow for the exploration of a data into the discovery of novel potential useful patterns that may not be appear the most of the outset. So appearing from the outset, what will happen? It will exploration is also possible and low cost. Obviously, when the raw data and polished data, there is a different kind. You can say that raw data will be cheaper, like crude petrol and all. After that we are doing some process and we are getting as a petrol, diesel, something like that. So the raw data is a cheaper. That's why we did not do the labeled data here. That is the reason, and also time consuming. You can see that we don't want to label or anything. We take it directly from the resources. So another thing is more complex tasks compared to the supervised learning, because an unsupervised you don't have labeled data. That's why complex problems also we can able to do this process. But preferably it is easy to get unlabeled data when compared to the labeled data. And the disadvantage, you can see that more difficult than supervised learning. Again, same problem. It does not have corresponding output, and that is the reason it is a bit complicated. Useful for unsupervised learning algorithm might be less accurate as input data, because as I shown you in the case of what we called as dogs and cats, by observation we can see that there is a no, cat and dog are a bit similar in the wind, but particular images I'm telling. In that case, because we are not trained, this image is belongs to cat, this image is belongs to dog or something like that, and it has to predict themselves to identify, and there is a chance of identification problem. Sometimes dog may represent as a cat or cat may represented as a dog or something like that. That is the reason we can say that when compared, because supervised is there also they have drawbacks very well, but supervised we already trained the data, and in that model if it comes you can easily identify, the accuracy will be more. But what is the drawback in supervised learning? In that supervised learning, whatever you trained, suppose you train in, let consider unsupervised case, you are training the dog and cat, and if you ask you to identify a new thing, then what will happen? In the case of supervised learning, it is difficult to find out because it is not trained within that pattern of data. It will give you the wrong answer. So but whereas here in the case of segregation, because of the features bit similar, in that case there is a chance of getting as a wrong answer. So that is what disadvantage in that case. To measure the accuracy effectiveness due to the lack of predefined answers, that's why it is difficult. Often have less accuracy. and use need to spend time because of this data not labeled. It may required as a more time. Lack of guidance is required because in the there is one teacher and student concept, but here he has to learn by self-learning. That is the one. Sensitivity to the data quality also as well. Sensitive data quality means including missing values, outliers, and noisy data that leads the efficiency of the model reduce because of that. And scalability, computationally expensive for large data sets or complex algorithms which can limit the scalability. These are the some of the problems in a supervised learning disadvantage, or you can say. And applications, we can use news sector, we can use it. Google News use unsupervised learning to categorize articles on the same stories from various online news outlets. So what it will do is, suppose in the news hunt and all, you remember once if you select, there is a lot of categories it will show you in the main while you are registering there. It will show political and education news, sports news, and cultural news, something like that. A lot of headers are there. If you select one category, and in all newspapers, whatever the similarity type of data is available, it will share to you so that it is easy, the segregation. The suppose if you select the political news, that all type of political news it is comes, or if you select as a state. Or if you select as a district also, that information is going to be displayed. That is one advantage. Like what I given you categorize under their label of US news or something again. Computer vision, this used for the virtual perception task such as object to recognition, that is on medical images process application, anomaly detection, then can allow large amount of data and discover a typical data point without within a data set. So these are all some of the applications as well. Now customer persons. So what will happen is now defining customer person. mm, Makes it easy to understand the common traits. So about the business clients or purchasing habits, all these things. Suppose if you go to supermarket, they may be identify what type of items you are going to buy with the details of the past data. In the because you are groups under category. I will show you later point of time how we are going to discriminate that category and all. And then recommendation engines. I mentioned already, using past purchase behavior data, unsupervised learning can help to discover data trends that can be used to develop more effective, that's what recommendation. So like if you buy a bread, then that will recommend you to buy a jam like that. Or if you are buying a computer, it will show you the end computer plus mouse, it shows some cost, something like that. Computer plus mouse plus something headphones or something like that. So it is a many combination, a cup and saucer, such kind of things are also possible. Now we'll see the supervised and unsupervised comparison. Input data time. What we'll do is algorithms are trained using label data in the case of supervised learning, and whereas in the case of unsupervised learning, not label data. Computational complexity, it is simple method because input output both is there, but is a computationally is a complex. Accuracy wise, again this will be accurate. All for this reason is what the data is not labeled. That is only thing. The number of classes is known, but number of classes are not known because while you are training this classes, we cannot be identify in prior in the case of unsupervised learning. Use offline analysis. There is a real-time analysis of the data is required in the case of unsupervised learning. And then linear regression, non-linear regression, random forest, support vector mission, neural network, all this comes under type of supervised learning algorithms. And whereas here k-means clustering, hierarchical clustering, a priori algorithm. No, prior algorithm. These are the three methods are available in the case of clustering. So we'll discuss that in the third unit anyhow. And desired output is given, but here desired output we don't know. We need to segregate. Another one is a data size. Use training data for infer model, but no training data is used here. Complex model, it is not possible to learn large and more complex models than in the supervised learning, with the supervised learning. Whereas in unsupervised learning, more complex models with unsupervised learning is possible. And then we can test our model. We cannot test our model there, and they called as supervised learning is also called as a classification, whereas here this also called as a clustering. So supervised learning types again, classification and regression, unsupervised learning, clustering, and then data reduction. All these things comes under the unsupervised learning. Optical character recognition is also possible. Face in an image, that image processing also we can use this. And as I discussed, just I'm showing once again, classification is nothing but a just we are going for as a yes or no or true or false. This category belongs to this or not. Like that, classification will be there. And, whether is a like yes or no or one or zero or something good or bad or something like that. And then regression, target variable is a continuous interval. So the regression is a continuous and there is a classification is a discrete. Another one, unsupervised two things. One is a clustering, another one is a pattern mining, and the clustering again came means hierarchical clustering and so on. Pattern mining is mining association in the data, and then prior features pattern mining and all. These are the classification. Now the third one, because total is four, and third one is comes under semi-supervised learning. Now the difference is here, supervised learning is labeled data, unsupervised learning is a labeled as data is not there, means unlabeled data, and semi-supervised learning in a data set, some portion of the data set will be labeled and maximum portion is unlabeled. That is what in the semi-supervised learning we can see is supervised unsupervised combination again. Small amount of label data. I can see that label data is small in the sense supervised learning, and a large amount of unlabeled data is nothing but a unsupervised learning. Particularly useful when a large amount of unlabeled data is available. So, but it is too expensive or difficult to label all of it. So the thing is to identifying that the data is complicated. It is too expensive if you want to label to all of them. And for our case, in the semi-supervised learning, one of data set, we have to take it as a supervised. Training data will be as a labeled, and some portion is not labeled, and the total maximum portion is a unlabeled data. In the case of semi-supervised, it can happen in applied when the supervised learning also applicable. Now, both labels and unlabeled data for training purpose. So what we'll do is, suppose if you train only the label data, after that prediction you want to do unlabeled data, it is a difficult. That is the reason we have to train both of them. Labeled data we need to train and unlabeled data also you need to train. This is a lesser amount of labeled data preferably in the data set itself. So maybe HOD and one more senior faculty or something like that. What you can do is labeled data and huge quantity of unlabeled data, we can able to train them. And because unlabeled data is cheaper, to acquire as compared to the labeled data, because the raw material or raw data is cheaper. This type of learning is used to approach classification, regression, and prediction case, labeled case, that one. And you can see that semi-supervised learning, we can notice the two things. There is a unlabeled data in this side and labeled data is there, but labeled data is small quantity and unlabeled data is a huge quantity. So in that it is going to be feature extraction and then selection of multiple sizes of features, and this side unlabeled data and feature extraction, K means clustering. So now this is one of the algorithm to make use of labeled data as well as the unlabeled data. Then the model is going to be developed by training the labeled and unlabeled data. And once the new data set comes, let it be this is a new data set, and if it is given to the clustering or classification wise, we can say that it is possible for predictions. Now, some more also are given the algorithm as supervised learning. Student is under the supervision of teacher at both homework. Now, what I'm doing is I'm trying to analogy between teacher and then student with respect to supervised and supervised learning algorithms. So, in a supervised learning algorithm, what it is going to be teacher at both the school and homework. Both cases, there is a under this teacher only is going to train. That means it is a supervised learning algorithm. In unsupervised learning, student has to figure out the concept himself. So their teacher will teach you to learn, but whereas here in unsupervised learning, he has to identify his problem and he has to learn by his own. But whereas in semi-supervised learning, where a teacher teaches a few concepts and in class and give questions as how homework that are based on the similar concepts. So we are giving the assignment or something like that. We are based on that he has to develop the concept. Homework and all he has to do in a class because it is half of that way we can say. Whereas in supervised learning, what will happen? No teacher teacher is there and they will train you. And unsupervised learning, no teacher, you have to learn by themselves. And then in the semi-supervised learning, what it will do is it will one teacher will teach you in the class and homework we have to do in the by our own. This is what example of semi-supervised learning. You can say that text classification. In text classification, goal is to classify a given text. Goal is to classify a given text into one or more predefined categories. That is a text classification. Train a text classification model using a small amount of label data. As you know that while you are training, small amount of label data is required and a large amount of unlabeled data is required. So in a semi-supervised learning, both is required. Some portion it is going to be trained and supervised learning case, and unsupervised learning case. What will happen? Some data is labeled and some other data is not labeled. We have to train both of them. And examples, you can see that anyhow, the theory part is with you. I will explain what is this, where we can use image classification, we can use and can be train an image and using a small amount of labeled data, a large number of unlabeled image data is going to be retrieved. So anomaly detection, that means the goal is to detect patterns or observation that are used often different from the norms. These are the detection of the pattern or objectives. So pattern and objectives we have, and speech analysis is there. Internet things application is there, and something even the Google search or Google Translator is there, and then potential sequence classification. So different kind of algorithms. This will be sequential classification is also possible. And of course, once they have an advantage, obviously there is a disadvantage as well. Disadvantage of this thing is, in the case of supervised, data set has to hand labeled and machine learning algorithm. This very costly process. This is a basic disadvantage of any supervised learning. The labeling is a costly manner and easy to dealing with large volume of data. Basic disadvantage of unsupervised learning is that application spectrum is limited. So the very small categories we can use it. And disadvantages that concern semi-supervised learning was introduced. Algorithm is trained upon a combination of labeled and unlabeled data. Now, your combination is very clear. Very small amount of labeled data and very large amount of unlabeled data. And the some more disadvantages you can see. Data science again is very costly process. Is in unlabeled data is spectrum is limited. This what I made it. And the last one is reinforcement learning. What is reinforcement learning is here? So robotics, gaming, and navigation. So all these things will be the reinforcement learning. How it has to be moved in its own directions and all. That's the reason I'm saying navigation. And nowadays very efficient gaming mechanism. So algorithms also there. So this is very good topic to work in that area using machine learning algorithm and robotics also, how that is going to be moved, because for robotics nobody is help to supervise the robot. So we are simply trying the model, nothing but a model. Robotic is nothing but a one model. Once the model is trained and if you send to buy something and milk in the supermarket, it will go and it will buy milk for you. So that is the how it will do. Yeah, it is very interesting concept actually. We'll see one by one without missing anything. There is a types of reinforcement learning also there. We'll discuss that in punishment basis, or you can say that appraisal basis. So something that kind is there. If you do something, there is a two ways to learn. We can say you should not do that if you try, and he will remember and he will not do next time. And otherwise also, if he or she are doing mistake and we have to do punishment. Suppose if he's not listening word, the kid something is doing some mistakes in a house. What mom will say is that I don't want to give you permission to watch TV, or I don't give to mobile, or don't give to gadget, or something like it is a punishment fashion. So that what it will do, the kid will train. Okay, he will remember this kind of things in many cases. Okay, I should not do this. I have to do this. And another thing is if get good marks or grade, I will give you a gift for you. That is also reinforcement. Our punishment also is reinforcement. So meaning is the two kind of things to learn, but it is all about no supervision, nothing is by practice, trial and error base. That will be there is a three main components in that. One is agent. That agent is a learner or a decision maker, like you can robot, like in this case. So learner or anything, I can say that the decision maker is nothing but what he has to do, like while you are playing a chess. So now how the chess will operate, nobody will teach you while you are playing all these things. That itself, okay, if I do this move, what will happen? Whether we'll get the punishment or we'll get the appraisal, something. Okay, if we get punishment, I should not do that way. That direction is you have to change. We'll move next step. Like that, it's all self-learning directly or thinking. Agent will be there, and then environment. All other things which agent interaction. So environment in the sense how the society in the outside it is acting. Whether if you do this way, what will happen if you do that way, and then action. So by doing this mechanism, closed loop path, what agent can do. So first is the decision maker. Let us assume that we want to move one step. Then what is the environment? Whether you will get gain or you will get lose. So based on this, no agent will act. What it will do, whether he's going back or not. So is remember that we will get the punishment or we will get something more benefits way. So you will identify that and he is going to implement. That is the mechanism in the reinforcement side action, which maximize the expert's reward over a given period of time. So if it is continuously training, it has to improve his skill and thinking power. All these things is come into the picture. Agent will find the destination much faster by utilizing the best policy with respect to given environment. So it has to identify the faster rate, so to reach that, suppose puzzle, you start in books and all, in a Sunday book or something, what we'll do, we'll start somewhere and we're moving that in the different direction. If you go the other way, and there your entry will stop and will close there. Or like that, you have to, now what it will think, okay, you should not go this direction. I have to come back and we have to move another direction. Then again it will learn. Suppose in other direction you are moving positively, you will remember that it is appraisal. So then if you keep on going that way and identification, these are all about the reinforcement. Aim of reinforcement learning is to acquire the most suitable policies. Now you can see that agent is there, environment is there. As per this logic, there is one is agent, another one is environment, another one is action. So these are the things are available here. This is the input data, and then reward and best action. So this is the whether we have to give the reward, means it is a direct way, and if it is not in good direction, you have to punish it. So that also there is a different kind of approach. Anything you can follow depends on problem, and we'll discuss while giving that numericals and all. And then output, we can observe that it is all the group of data, and then it is clustered. These all maybe different places, but it will be one group, and there is another group, and then next third group. So these are the reinforcement learning black diagram will be there, and what it will use in as a feedback type of algorithm. This is all about feedback type of algorithm. We have to get the feedback whether it is a positive or not. If it is not, we have to modify there and we have to update that attendance. So in other words, this results gives the feedback to the model under training purpose. So we can take the concept of giving rewards for every positive result, and then based of our algorithm. This is one way I said now, positive reward. We have to give the reward for every positive result. So if we get one good result, we'll get the positive. Or if you writing exam, let us do that. So if you pass, that is a reward, you will get the attendance. If you fail, you don't get the. That is the kind of thing we need to proceed in this reinforcement learning. We can train our dog. This also one important you can remember. Suppose you are training a dog to perform certain action. So I am giving instruction, go to supermarket and buy a biscuit for me or some other, go and bring milk or something else. And you want to, what you want to do is order the dog to certain action for every proper execution, we have to give one reward. So suppose in this case, I'm giving as a biscuit to our dog. If he executed perfectly, the dog will remember that certain actions will get the biscuits. Okay, by doing this mechanism, if you do that way, and if you do another thing, if you play cricket in house, you will get punishment, you go outside, something, that kind of thing. It will try in all aspect. It is environmental situation. So not only one particular topic, by other topics also, by time to time, it is going to be whether it is getting award or reward. or some kind of things is going to be, and you can see that it will get the biscuit. Dog will remember the action. So okay, if I do this, I will get the biscuit, and it will follow the instructions properly next time. So next time what will happen? Or if it is punished, if we yes or no category, if one thing is happened, you will get punished. Then next time it will, and the situation comes in the same manner, that will not be do. So they will go other alternate options. So like that, you can see that example as a human child, like I mentioned, the kids, make a mistakes in house. Then what they will do, the train not be repeated it again. So if you done any mistake, and adults try to make sure that, or we can say that indirectly, try to not to repeat it again. In case, suppose the feedback concept. If the parents are strict, what type of feedback you will do? Scold them for the mistake. So then what the child will remember, okay, I should not do this in the next time. By doing this, I will get the punishment. So I should not do. That is one remember. Other thing is what? That is a negative type of feedback. In the positive type of feedback, what we can do is, um, this is what negative child will remember it. If it does the certain wrong action, will get the scold. And then positive feedback is what? Where the parent might appraise. So just praise them doing something right. So these are the two things. One is a negative thing. Another one is a positive feedback. Negative feedback in the sense, if actions are taken wrongly, we can scold them. We will not repeat next time. If you do rightly, if you appraise, okay, good work you done, and then okay, if I do this kind of things, it will maybe positive signs. Like that, we are forced to try to certain ways, and reinforcement learning methods. We given reward of feedback to the algorithm to learn from the improve features in the result side. Now you see some advantages. It can solve higher order and well. Solution obtain is very accurate because it is all robot learning. Punishment wise or appraisal wise, it is societal impacts. All it's going to be involved in this. Very similar to the human learning technique. This also model will be undergo a rigorous training process takes place in time that can help to correct any error. So this is the reason we can say that reinforcement learning is required in each laboratory. That way also we can do things. So now due to its learning ability, it can be used with neural networks. So that is what we can call it as a deep reinforcement learning. That means it is involved in major aspect. So therefore, due to its learning ability, for used with neural network also you can use it. And model learns constantly. Mistake made, yeah, easier would be unlikely to occur in the future. So various problem solving modes are possible to build, using environment algorithm. And when it comes create simulators, object detection, cars, robots, and plays great role in this model. Best part of this, when there is no training data, it will learn through the experience. This is what very important. Through experience, it is going to be learned. That's why accuracy will be more. And various complex problems also it is going to be solved. And disadvantage case also, uses of reinforcement learning model for solving simple problems won't be correct because it is all decision making. It takes use rigorous training with the stepwise all different categories, different style, and different of impact. All these things we can able to train. That is the reason it is very complex training process. Was unnecessary processing power and space by using it for similar problems. So wasting of unnecessary processing. Because we are want to train this much training for the similar type of kind also we need to train it. We need lot of data to feed the model for computation. This requires a lot of training data and to develop accurate result as well. The consumes time because is the data is huge. That's what this consumes time and lot of computational power also required. And when it comes to building model, a real world example, maintenance cost is very high, and driverless vehicles or robots like this kind of applications we can use as a reinforcement learning. And the other thing is business side, we can use it. Gaming application, you can use it. Recommended systems. Another one is science. This kind of things we are going to apply. And one is reinforcement learning, or RL, we call it as in business, marketing, and advertising. For that, you can use it. Money-oriented fields, technology can play a crucial role. Like reinforcement learning model of companies can analyze the customer performance and help them in the better way. That is also important based on the data set. And we know that business requires proper strategy. The steps need to useful planning and product or a company to gain profit. This is the thing, and helps to devise power strategies by analyzing the various just a minute. And this is the way we can able to help to devise proper strategy by analyzing the various process that tries to improve the profit margin of the results. This is the way we can able to go for application. And similarly, some more I given reinforcement learning in gaming also we can use it. And I given some theory, you can read it later also. And another one is reinforcement learning for recommendation system. This is what I already mentioned, the app recommendation. Big help in the recommendation system like news, music apps, web series apps, Netflix. So for customer the preference we can able to select. And web series apps like Netflix, variety of shows. Once if you watch one type of movie, let assume that in a Netflix or somewhere, and they will show you the relevant of kind of movies they will recommend for you. Or even in Google Scholar citations there, if your publications are in one area. Suppose let it be, it is a power system area in that specifically one particular area, let us assume that, or maybe machine learning area. So whatever other publications comes in the followers, the similar kind of publication, they will share to you, this is the recommended publication for you. That means what? You are working in that particular domain. So therefore, this kind of work is going to be suitable for you to refer. That kind of things is possible here. That's what I mentioned here. Model will show the training shows all these things. If you see one kind, the training shows also will show you in that. And another one is reinforcement learning in sciences also we can use it. Artificial intelligence and machine learning techniques become an important part in a research. Various fields in science, reinforcement learning can come in a handy. And reinforcement learning help to understand chemical reactions. We can try to try cleaner reactions that better production, all these things is possible in the science area also. We are using as a reinforcement learning. Better quality results will obtain by this process. And types of reinforcement, as I mentioned, two things: positive reinforcement, another one is negative reinforcement, that way. And positive reinforcement receives the type of reward for certain result, and we try to add a reward for every good result. That means So we want to give as a positive signal. If you do something, we can give reward. If not, then you don't give it. So that is the way. Try to add a new reward for every good result in order to increase the likelihood of a good result. Example, you can see that child do certain task like cleaning their rooms or studying hard to get marks. Some parents offering as a promising them to give reward. So some kind of reward at the end of the task. That means what is training, because if I do such kind of works, I will get a reward. Like promising to child something to buy or give chocolate or something. Automatically makes the child to think to go in terms of the reward side. And other one is negative reinforcement learning. And this is also similar, but we are punishing. That instead of giving reward, we will go for as a punishment side and try to remove something negative in order to improve the performance. So a bit difficult for the positive reinforcement type of that. But here we try to remove something negative in order to improve the performance. But you can say that child parent example here, some parent punish the kids for not cleaning their room. Both are learning mechanism only, but is quite different. There, if they do, they will give. If not do, they don't give. So, but whereas here, if he is not, because his responsibility to do, but he's not doing, we will punish it. So that is the punishing for the not cleaning the room or something. And you don't give the video games or 1 week or 1 month, and I will not allow you to go to movie or something kind of punishment we are doing. To avoid punishment, what kid will think, if you do punishment 1 time and 2 time, then he will think. That's what the thinking power will improve, to improve his performance. To avoid punishment, the kids offer work hard or complete the job assignment to them. So this is the different. Now we'll see one more reinforcement learning versus supervised learning. I've shown you in the one previous slides, supervised versus unsupervised learning. Here, similar fashion, there is reinforcement and then supervised learning. Output depends on the state of the current input, because output we are getting based on the input here. But in the supervised learning, the decision is made on the initial input or the input given to the at the start. So whatever we trained, that will be input based on that. But here, what will happen? You can see that the next input depends upon the output of the previous. Suppose he moves one, whether he will get the positive reinforcement or negative reinforcement, based on that, he has to decide the next step. Based on the previous step only, he will decide the next step. And then another thing, a decision is dependent. So we give the label to the sequence of dependent decisions. So we have to give label, because if I do that, whether this label is yes or no, or it is not true, I cannot do that, or punish or punish. So these kind of things, chess games or summarization, all these things. Whereas in the supervised object recognition, spam detection, that kind of application will use there. Now, briefly, whatever we've done so far, I will summarize in the pictorially, so that it is easy for understand. These are all things are very simple. You just read once and twice and you'll remember something and write it. It is very quite simple when comparatively all our in conventional electrical subject. What in conventional electrical subject, we have to remember and we have to solve many of the equations, design, but whereas here, nothing is there. Suppose one topic is there, a classification or a regression types, or types of machine learning or reinforcement, or what is happening is on theory. You just remember once and twice. If you read, you can easily remember the different wise classification wise. What is the supervisor, what is unsupervised, what is difference between these two. Then we'll go for as a semi-supervised or maybe reinforcement. What is the comparison? What is the different? If you remember that way, we can easily write our sentences in exam very simple manner. Now you can see machine learning completely what it is, the sequence. First definition of the problem, whether it is a supervised learning or unsupervised learning or a reinforcement learning. Supervised learning is already mentioned that there will be label data will be there. He will train it themselves. So now it will be, we can see that reinforcement learning agent interacts with its environment by producing the action. So agent interacts with environment. So this is the agent. You want to do something environmental, then we'll get back the result. Whether result is positive result or a negative result, based on that result, we can easily, do his action. So that is all about the first problem definition. So now the types of problems, what are the problems? In a supervised learning, we have two things, because I summarizing all the things. What are the two things? One is regression, another one is a classification. So these are the two types of the problem. And unsupervised, what are the problems? The association problem and clustering problem. So in a clustering problem, we can notice that all these categories, it is a green color, let us assume that one group, this, or we say that one cluster, this is the another cluster. And then reinforcement, you can see that he want to, start here and you have to exit here. If you exit, you will get, something price, but he is not able to reach, he will not get it. So he will think that how to reach that, the next time, next move will be there, and next move like that, finally is going to be achieve this. This is very accurate and it will take but time. And that is about the problems. Now types of data. What is the types of data we have? In supervising, label data is there. Unsupervised, no label data. And then no predefined data is required. So we will not have, we don't try and past data or something existing raw data and all. What we will do is we are able to do, agent will be there, it will interact with the environment, and then we will take a step. So that's what reinforcement will do. And after that, training. What is the training here? There is a coach or a father or maybe something teacher, and then another one is a student. So there is a external supervision is there, how we are performing. No, he will correct you. If you do mistake, he will teach you to make correction. So then what will happen? That will be as a training aspect, one thing. And other one, no supervision. And then that is also called as an unsupervised learning. She has to, do practice. So while he's doing practice, he has to get the, training, whether we is wrongly is playing or rightly. But whereas in the supervisor, he will teach you. If you play wrongly, then he will teach you, but nobody is there. So you have to learn from the experience. And then whereas in the reinforcement, no supervision, he has to think and he has to do the works. That is the training. Now what is the aim? Now in that, the problems are there, and then we trained, and then forecasting the outcomes. So what is the outcome? Based on the input, he has to decide, this is the your outcome. You have to forecast the outcome. In the unsupervised case, discover the underlying pattern, because there is a different kind of patterns are there. It is belongs to which pattern you have to recognize. And you can see that session of action. So the learn, based on the action, he has to learn. That is what the is aim. And then approach. So what is your approach? You can see that there is a map labeled input to known output. So it is mapping input to output is direct mapping. That's what the classification and the regression will do. And whereas in the underlying patterns and discover outputs, that means explore patterns and trends. That is going to be your approach. And then whereas in the reinforcement learning, again, flow, trial and error method. So it is trying, if it moves something, then we'll stuck here. Then what will happen? There is error. He has to learn. So I should not go this way. Then he will go something else. So like that, he has to learn something, and then has to finally he has to come out. So that is the way will go for the approach in the case of reinforcement learning. Then output feedback mechanism. So it is a direct feedback, because person is there to watching you, and if you do mistake, he will give you feedback about that. But is what about this? In unsupervised, nobody is there. He has to train. That's why no feedback is there. And reinforcement learning reward system, input state, and then based on that you will act environment, and then you will get the feedback, and then whether it is a reward or punishment or anything, and based on that you will do further. And then there is a popular algorithms. So what are the algorithms is there in these areas? One is supervisor algorithms case, linear regression, logistic regression, support vector machine, k nearest neighbor, random forest. These are all about the supervisor. For all these things we required as a labeled data. And similarly, clustering case, k means clustering, and then a prior, and then c means this type of algorithms, we call it as unsupervised. And this also Q learning, and this is another algorithm. There is a different kind of algorithm. These are in the reinforcement learning algorithm. And finally, applications, you can see that where we can apply this kind of algorithm. So this is the thing, risk evaluation, forecast sales, and then recommendation system. In the case of unsupervised learning, we have to recommend to which type of apps we are going to be, or similar way. And then anomaly detection, and then self-driving car. This is what gaming. It is very accurate, and thinking power. So by training only it will know when object comes, the car has to slow down. So this kind of things will be there in the reinforcement learning. So this is the total approach of machine learning algorithm, starting from definition to go for the up to final end as application. This is the brief of this today's lecture, and we'll see in the next class. If you have any doubt, you can ask me. Otherwise, you can leave. I will take attendance directly from the this. And if you have any thing, class adjustment, all these things, you let me know in a group, or you may be called to me or something. Okay, done. Okay.
Sir.
Yeah.